Okay, so remember yesterday we talked about position versus time graph. And let's say that, position versus time. Let's say that we've got a graph that looks like that. Looking at that graph, what can you tell me about the velocity of this? It's constant. Why?
Straight
line. Okay, so the point I need you to remember is that on a position versus time graph, what tells you the velocity? The slope. Okay? If the slope is constant, your velocity is constant. If your slope is not constant, is your velocity constant?
No.
No. Because if you look, this, based on how this works, position, you seem to be speeding up. You're getting more change in your position as the time changes. So you have to be speeding up. Okay? Well, let's see if we can make this connection. Velocity versus time. Let's say right there is 0 meters per second. What do you think acceleration has to do with the velocity versus time graph?
The slope.
The slope is the acceleration. So, position versus time, the slope of a position versus time graph is your velocity. The slope of a velocity versus time graph is your acceleration. And we're going to talk about how you got negatives, you got positives, and all sorts of different things. Okay, we're going to come back to this in a little bit, but I do want to continue on here with acceleration. All right, so here's an equation. You're going to need to get it into your note card if you have one. Anybody not got a note card yet? Everyone good? Got a note card. All right, start writing this in your note card. Wait, write it small. Otherwise, you are going to need multiple note cards.
Are we allowed to have more of those?
You're allowed to have more than one. Yes. Alright, so acceleration is a vector quantity. What does that tell us?
Magnitude and direction.
Magnitude and direction. You hear that, Mr.
What? Magnitude and direction.
Alright, so we need to have directions with acceleration. Now, notice what this says. It says an object accelerates if its speed and velocity. I don't know why they use speed. If it's velocity, direction, or both changes. So notice something here. You are actually accelerating when you change directions. So when I throw an object into the air and when it gets at its peak and it's technically stopped, right? It is still accelerating because it's going from going up to going down. That takes acceleration. Now, bear with me. That's probably a mind-blowing phenomenon. But it is accelerating. We're going to talk about that as we continue on. Okay? Mind blown, Isaiah.
My mind is already pushed.
Okay. So, if velocity is changing, you're accelerating. What if velocity is not changing?
It's not accelerating.
Okay. So, if I have a change in velocity that is 0, you're not accelerating. So if a position versus time graph is a straight line, are you accelerating?
No. Yeah.
Well, like horizontal?
No, not accelerating.
Either way. So if I have a position versus time graph that looks like this, what does that tell me about velocity? It's constant. A constant. Are you changing velocity if your velocity is constant?
No.
No. So your change of velocity is 0. Does that mean you're going 0 meters per second?
No.
No.
Okay, never mind.
Okay? Be like putting on the cruise. So, my acceleration is 0 here. My acceleration is 0 there. My acceleration is 0 there. And my acceleration is 0 there. Does that mean my velocity is 0 at all those points?
No.
No. Some points they are. why did I make this circle all these points? Why is that? Did you notice some connection between all of those?
They're flat.
They're all flat. What did we say acceleration is in regards to a velocity versus
Slope.
time graph? The slope. All of those places have no,
Slope.
they're not accelerating. Okay, now, there's only 2 of these places where the velocity is actually 0. Where is it?
Oh, it's on the line.
Here at 0, and here at 0. We are still moving here and here. Okay? But we're moving at constant velocity, so therefore we are not accelerating. Okay? This is moving at constant velocity in the positive direction. This is moving at constant velocity in the negative direction. How do I know negative direction? Well, what would this be? -1 meter per second. The negative tells me direction. Got it? All right. Now, I want to show you, let me see here. So here's a velocity versus time graph where it's not as staggered as I have it, right? All right? Here we go. So the slope of the velocity versus time graph tells us acceleration. Okay, so there's your notes where I'm getting that from. Okay, let's just look at point A. Okay, it says when the velocity in the positive direction is increasing, your acceleration is positive. That makes sense, right? Okay, when the velocity is constant, there is no acceleration. That makes sense too, right? Right, there's no slope here. When the velocity in the positive direction is decreasing, your acceleration is negative. So I'm going in the positive direction, but my acceleration is negative. How?
Because you're slowing down.
I know that's kind of hard to understand. I think it'll help us if I give you some actual math examples, I guess. So you may want to put this in. Okay, so we have this equation. So we said average acceleration was what? And I'm just going to do change in time. I'm not going to do TF minus TI. Okay? So there's our equation. Let's give some examples. Now we remember that if I have a positive velocity, what does the positive tell me? I'm just going in the positive direction, which could be either one of 2 things. What could it mean? It could mean up, or it could mean east. Because, yeah, it depends, right? Because what is forward? Forward is, which way is forward? Right, you see what I'm saying? Okay? Now, what if I say I have a negative velocity? What is that telling you?
Down.
Yeah, either south or west. Okay? So, let's say that we're going in the positive direction. So what is that going to mean from a velocity standpoint? Always.
Positive.
Always positive. The V will be, we'll go positive V. That make sense? Okay? Now does that mean the change in V will always be positive?
No.
We'll have to see. Okay? So let's say, situation 1 here. Say I am speeding up. But I'm going in the positive direction. So if you're speeding up, is your final velocity going to be bigger or your initial velocity going to be bigger? Your final, if you're speeding up, correct? Does that make sense?
Yeah.
So I'm just going to use some numbers here. Let's say I'm 20 meters per second final minus, initially I was 10 meters per second, and I did it over a 5-second window. Okay, I'm just going to give you some numbers here. Does this agree that I'm speeding up and they're positive? The only reason this is negative is because the equation is negative. Does that make sense?
Yeah.
Okay? So I would have, what is that? 2 meters per second squared. So speeding up in the positive direction gives me a positive acceleration. Isn't that what A said on the previous slide? Make sense? Okay? Let's say,
Hey, Chris,
yep.
when you're writing 2 meters per second squared, you have to put a positive in front of it. Or can you just say?
We can arbitrarily, if we don't put a positive, I should put direction is what I should really do. Like give it a north, south, east, or west. But yeah, it's arbitrarily assumed to be positive, I guess, if you don't put it. Yes?
So like if you're going, that 20 meters per second is going east, then you do like a U-turn and that 10 meters per second is going west, then would it be minus negative 10 meters per second because you're going west? And then
Yeah.
it'll so then
Yeah.
negative 30.
Let's not get, because that's not one directional motion anymore if you're doing a U-turn. So let's not get into that yet, right? If you were to stop and then go in reverse on the same plane, does that make sense?
Yeah.
Yeah. All right, so let's say now we are constant velocity. So I'm going to give you every situation here. So what is constant velocity going to tell us then? Your change is 0 because if my final and my initial will be constantly the same. Does that make sense? So 20 minus 20 over 5, what is it? So anytime you're going at constant velocity, are you accelerating? No. Make sense? Okay. Now let me show you the one that doesn't make as much sense. Slowing down. If you're slowing down, you're going in the positive direction. Is your V final going to be bigger or your V initial going to be bigger? V initial is going to be bigger. So let's say that my final is 10 and my initial is 20. Do you see how this gives you a negative acceleration? That is right here. What's the slope? Positive or negative? Negative. Speeding up, constant, slowing down. But we're still positive V, aren't we? In all three of these situations, my V is still positive. It's still above the 0. Make sense? This is really important this will make the conceptual stuff a lot better if we can understand this. What?
How is your V positive, but when you do the final minus initial?
Because of the equation. I'm putting a positive number into the equation, and by default, it's making it negative. Right? Okay? Yes, sorry. All right, now let's do this whole thing, but now let's do it in the what direction? Now, you don't have to. I'm going to probably go through this a little bit quicker. And I'm not going to go through this one because it's going to be the same. It's just be negative 20 minus a negative 20, which would be a 0, right? Make sense? Negative 20 minus a minus 20 would be 0. Okay? We'll just change that. So now negative direction, that means all my velocities are negative. When I'm putting numbers in, I'm putting in negative numbers, correct? Okay? If I'm speeding up, the final or the initial is bigger? Final is bigger. It's a bigger negative number. Negative 20 minus negative 10. Everyone's seeing that? What's my acceleration now? Negative 2.
When you said it's a big number, it's actually a
Quantity, like without a sign.
Okay.
I was like,
Yeah, bigger number is in bigger magnitude.
Okay.
Yeah, absolute value. So now notice, when I was going in the positive direction, speeding up gave me a positive acceleration. But if I'm going in the negative direction, speeding up gives me a what? Negative acceleration. What do you think slowing down is going to do? Opposite. So we're going to go negative 10 minus a minus 20. Those become positive. See it? Okay. Now, I'm just going to give you, I think you guys have it in your notes. If you guys have a big table that kind of breaks that all down?
Yeah.
Okay, so you have that table, so then this would be the negative thing I just showed you. Okay, negative direction, speeding up, negative direction, slowing down. Positive slope when you're slowing down in the negative direction?
No.
Positive slope.
Oh, that one.
This is a positive slope when I'm slowing down, coming from what? -1 to 0, that's slowing down. Okay? And speeding up, positive, or negative slope.
So when it's negative, it's just the opposite of positive.
That's a really blanket statement.
You're saying what it's negative.
So when it's
For
negative,
acceleration,
Yeah.
kind of, yeah.
Is negative the opposite of positive?
We understood. We understood what you meant. So I think it's this. Okay, this is really what I said, but it's more in a memorized type format. Okay? I would like you to be able to understand it. That's why I gave you the math behind it, so that you have something to support just memorizing this table. Does that make sense? Okay? So it's giving you the why behind the math, I guess. I think here, let's do some problems.
No. What are you talking about? She said a spider landed on
Yeah,
you.
there's
No.
like high-key aspiring there.
No. I don't know where it went. I saw
What
it.
the heck?
I saw it coming down from the ceiling. Like,
No,
Why
what
didn't you grab it?
Let it land in my
I
hair.
tried to like push it away.
No,
with my
get it
pencil,
out.
and then you
Pushed
moved
it
into
into
it.
your hair.
No, she moved into it.
I know. All right, here we go. Cheyenne, you don't have to
The size of the
deal with it. You eat like 4 spiders every year, so.
It's probably
When
your
you're
leg
sleeping.
aches.
That's actually not true.
Trying to help her out. Okay, here we go.
Wait,
A shuttle bus slows down with an average acceleration of this. So they told us that's acceleration. Before we do anything, label, 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 label. If I hammer, those took advanced chemistry, label. Right? So what is that? A, I know you, Coburn, you probably will never do it.
You too smart.
No, I'm just lazy.
Wait, what's the A stand for?
Will it ever just say like deceleration of this?
It could say deceleration, but I would still treat it, look at the context of the problem to see what you would do for a sign. Okay, now here they gave us a negative sign. They may not always do that. Okay, how long does it take for a bus to slow from 9.0 meters per second to a complete stop? So what is the how long referring to here? Change in time, not change in x. Because it's what's the time period it would take to stop. Now we got some other things. What's this?
That's the
How long did it take the bus to stop?
initial velocity.
That's the initial velocity.
But the initial or the final.
Okay, now let's look at this. Did it give us us directions at all here?
I mean, technically, with
Just
the
see it
negative
like a
and positive,
direction.
but
I'm going to assume it's positive then, since it doesn't give us a direction. And VF, everyone understand why VF is 0? Because it's stopped. Do you see the hidden information stuff you're going to have to look and decipher through?
How'd you get VF at 0?
Yeah.
This is
Oh,
going to
yeah,
complete
that's.
It is coming to a complete stop. So I'm at 9, and I'm coming to a stop. So when I stop, what's my speed? 0. Okay? Now looking at this, what type of equation am I going to use? Do you see how labeling will tell you the equation most of the time? Which equation am I using?
Acceleration.
Or acceleration.
Okay, so you're going to solve for change in t. Yeah?
Yes.
And then,
It's just 9.
no, it's -9.
Come on.
Because it's final minus initial, v final minus v initial.
so embarrassing.
That is so embarrassing.
So 0 minus 9, I should put in the units. I'm so bad at that, and it's not good. Divided by What's the
Negative
acceleration here? Negative 1.8 meters per second squared.
That's
5 seconds.
Yes, they should.
Sig figs would tell us 5.0.
0 seconds. Well, we're not worried about that.
Yeah, sig figs don't matter.
Now, if the stuff that you've been given is in your most common units, you can assume your answer is in your most common units, but let's make sure it works out. Meters cancel, 1 of the seconds cancel, so it's 1 over seconds, which is a second. An inverse of an inverse is
So
like 1 over 1/2, what is it?
1.
2.
What? Here, will you do the next one? For the buttons?
1 over 1/2, 1 divided by 0.5 is 2. 1 over 1/4 is 4. 1 over 1/8 is 8. Okay? Same thing with units. 1 over 1s is
S. Okay.
very simple.
Alright, I'm glad we did this problem because I would have forgotten to give you an equation that you're going to need for your homework. So, here's an equation you're going to need.
Displacement.
I mean, technically, if you read the
Thank you, Bryce.
Bryce, don't be that guy.
Oh, no, I don't really, but.
You're on it.
Alright, let's try to do this kind of quickly here. This is not a real difficult problem. A racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its parachute and braking system. It comes to a rest at 5.5 seconds later. Find the distance the car travels during braking. Okay, what's 41?
42.
42.
That's
Accelerate B.
That's the
Initial.
Okay, it should say speed, it should say velocity.
Initial.
It's V initial.
And then final 0.
Reaches a speed of 42, wouldn't that be the final?
Yeah.
That's that last speed that reaches.
So it's saying a car races to this speed and then it puts on the parachute. So we're not looking at what happened before. Does that make sense? So then VF would be, right, it's going to come to rest, it says it. So your VF is 0. Your time is 5.5 and it wants to know what?
The distance.
Distance, so this should say displacement. Again, this is bad. Displacement.
Yeah, that's probably why I didn't understand the log.
I don't know. It's all supposed to be displacement.
Well, you know what should be correct, fix it.
Okay, so it's negative. Wait, negative 4.
Okay, adding a 0 in there doesn't do anything. Oh wait, right? I didn't check directions, did I?
That's so
It's negative acceleration. Yeah.
Okay, we don't need acceleration. But let's see, are we going in the, it doesn't say anything about the directions. All right, time, what, 5.5 seconds?
Yeah.
So you see how the seconds are going to cancel, leaving us with meters? Which would make sense for a displacement unit, right? Should give us, I think, 120.
I got 150 quick runs.
Okay, 6 figs. This is the class where I hammer sig figs more than any other class.
Yeah,
I
no.
should probably review that.
Yeah.
That was
So
like
label
literally the first day.
for X. No, I remember them, but I just what's the label?
Label or unit?
So what's the answer? 110.
In this case, seconds cancel.
Oh, right.
Yes, I said.
So don't you need a direction for this?
No, displacement is different than direction.
What?
Displacement and direction are different.
What's the answer? But you need
I'm thinking about it.
5.0.
displacement has the direction.
For real? Okay.
Kind of.
It's distance with direction.
Kramer,
But,
on fire dropping out.
no, you're not.